Alright, this video is titled What is Velocity? We're going to be looking at velocity and another important topic called displacement. I'm winging it on this video, so if I screw up, don't laugh too loud at me. Alright, so first of all, velocity is the ratio of displacement and time, or in other words, displacement divided by time. And speed is the ratio of distance and time, or distance divided by time. So what's displacement and what's distance? Displacement refers to the length from the final position of an object as compared to its initial or starting position. So let's say that we're running around a track, and this is a standard 400-meter track, and we make both of our turns and end up back at the starting line and we're done. So what is our displacement? In this case, it's actually 0 meters, because we ended up exactly where we started. Now, distance is the length of the total motion of the object. So that's the key difference. We're not just looking at beginning and end. So let's say we run around the same track again. Again, it's a 400-meter track, end up where we started, but this time the distance is 400 meters. Because we're actually looking at where we went, not just the final position compared to the starting position. So if we look at velocity, my blue line represents the displacement. And I'm going to use a delta t, or a change in time, of 30 seconds. So this is going to take me 30 seconds to round this track. Definitely not me running. So my velocity equals my displacement, which is going to be represented by delta x over delta t, which is my time it took. We already said my displacement is 0 meters because I ended up back where I started, and it took me 30 seconds to do it. This gives me a total velocity of 0 meters per second. So according to velocity, I didn't move. If I run the same track again, this time looking at speed with the green line, my speed is going to be equal to the change in my distance, which I'll represent with a d, over the change in my time, which again is 30 seconds. So it's a 400-meter track over 30 seconds, and this comes out to be about 13 meters per second. And this is my total speed. So why do we care about the difference? What's the big deal? Well, velocity is a vector and speed is a scalar. And this is actually very important. If I have a velocity of 5 meters per second, I have a velocity in 5 meters per second in a specific direction. And that direction is found by doing the displacement. When I do my speed, it's only 5 meters per second, and I really don't care which direction I'm moving. So the root of the matter comes from figuring out where did you end up compared to where did you start. Okay, for another example, a ship sails 4 kilometers west and then 3 kilometers south in 3 hours. What is the ship's average speed? And what is the ship's average velocity? Yeah, I'm not an artist, but that's okay. So we're going 4 kilometers west and then 3 kilometers south. So my speed is equal to my distance, which is a total of 7 kilometers, 4 plus 3, divided by my time, which is 3 hours, which gives me a speed of 2.3 kilometers per hour. My velocity has to use the displacement. So if I use the Pythagorean theorem, since west and south are 90 degrees from each other, I find that I have a displacement of 5 kilometers southwest. So I plug this in. Velocity is equal to 5 kilometers over 3 hours, which gives me a total of 1.7 kilometers per hour southwest. You have to include the direction or else it's not velocity. Alright, that's it for this video. Took almost 6 minutes, so sorry for the long time. We'll see you tomorrow.